Hey there, science fans! Welcome back to another exciting episode where we unravel the mysteries behind the technology we use every day. Ever wonder what keeps your electronics humming? What makes your smartphone, laptop, or even your microwave work so seamlessly? It's all thanks to a tiny but mighty component, the crystal oscillator. This little device is crucial in ensuring that your gadgets function properly. These little guys are like the heartbeats of our gadgets, keeping everything ticking in sync. Without them, our devices would be lost in a sea of electronic noise. You see, electronics need a steady rhythm to function correctly. Just like how our hearts keep a steady beat to keep us alive, crystal oscillators keep our devices running smoothly. Imagine a drummer trying to keep a beat without a metronome. Chaos. The same thing happens with electronics without a crystal oscillator. That's where crystal oscillators come in. They ensure that every part of your device is working in perfect harmony, just like a well-rehearsed band. They provide a super accurate and stable frequency, like a perfect metronome for our gadgets. This precision is what allows your devices to perform complex tasks without missing a beat. This frequency, measured in hertz, determines how fast a device operates. The higher the frequency, the faster the device can process information. From your smartphone to your microwave, crystal oscillators are everywhere, making sure everything runs smoothly. Pretty cool, right? They are the unsung heroes of the tech world. Let's dive in and learn more about these tiny timekeepers. Stay tuned as we explore how they are made, how they work, and why they are so essential in our everyday lives. So, how do these crystal oscillators actually work? Let's dive into the fascinating world of piezoelectricity to find out. It all boils down to a cool scientific phenomenon called piezoelectricity. This term might sound complex, but it's actually quite simple and incredibly interesting. Don't worry, it's not as complicated as it sounds. Piezoelectricity is a property of certain materials that allows them to generate an electrical charge in response to mechanical stress. Certain materials, like quartz crystals, exhibit this amazing property. These materials have a unique internal structure that makes them special. When you squeeze or stretch them, they generate a tiny electrical voltage. This happens because the mechanical pressure causes a shift in the positions of the atoms within the crystal, creating an electrical imbalance. And guess what? The reverse is true too. If you apply an electrical voltage to these crystals, they will change shape slightly and start to vibrate. Apply an electrical voltage to these crystals, and they vibrate at a precise frequency. This precise vibration is incredibly useful in the world of electronics. This back-and-forth interaction between mechanical pressure and electricity is the key to crystal oscillators. These oscillators are used to keep time in watches, stabilize frequencies in radios, and even in computers to keep everything running smoothly. By carefully shaping and cutting the crystal, we can control its resonant frequency, which is the frequency at which it vibrates most strongly. This process requires precision and expertise. This precise vibration is what keeps our electronics in sync. From your smartphone to your GPS, crystal oscillators play a crucial role in ensuring everything works in harmony. So next time you check the time or use any electronic device, remember the magic of piezoelectricity at work. Now that we understand piezoelectricity, let's take a peek inside a crystal oscillator circuit. This tiny yet powerful component is the heartbeat of many electronic devices, from your wristwatch to your computer. Don't worry, we'll keep it simple. At its core, a crystal oscillator is designed to produce a precise frequency by harnessing the unique properties of quartz crystal. The star of the show is, of course, the quartz crystal. Quartz is a piezoelectric material, meaning it can convert mechanical pressure into electrical signals and vice versa. It's carefully mounted within a protective casing and connected to an electronic circuit. This setup ensures that the crystal remains stable and protected from external factors that could affect its performance. This circuit acts like an amplifier, taking the tiny vibrations of the crystal and boosting them into a strong and stable electrical signal. The amplifier circuit is crucial because the initial signal generated by the crystal is very weak. Think of it like this. The crystal is a tiny tuning fork, and the circuit is a microphone amplifying its pure tone. Just as a tuning fork vibrates at a specific frequency, the quartz crystal oscillates at a precise frequency when voltage is applied. The amplified signal then acts as the clock signal for our electronic devices, ensuring everything runs at the correct speed and in perfect harmony. This clock signal is vital for synchronizing the operations of various components within a device, making sure they work together seamlessly. Without crystal oscillators, our modern electronic world would be chaotic and unreliable. These tiny components play a massive role in the functionality and reliability of countless devices we use every day. Okay, time for some real-world examples. Remember those old-school quartz watches? Yep, those relied on crystal oscillators to keep accurate time. The crystal vibrates at a precise frequency, typically 32,768 Hz, which is then translated into 1 tick of the second hand. But crystal oscillators aren't just for telling time. They're everywhere. Your computer, smartphone, GPS device, even your microwave oven, they all rely on these tiny timekeepers. In computers, crystal oscillators regulate the speed of the central processing unit, ensuring smooth data processing. In communication devices, they help maintain stable frequencies for transmitting and receiving signals. Section 5, can you hear me now? Oscillators and communication. Speaking of communication, crystal oscillators play a crucial role in how we connect with each other. They're essential for radios, televisions, and even the internet. Imagine trying to tune your radio to a specific station without a stable frequency. It would be impossible. Crystal oscillators ensure that both the transmitter and receiver are on the same wavelength, allowing for clear and reliable communication. The same principle applies to cellular networks and Wi-Fi. Without crystal oscillators, our smartphones wouldn't be able to connect to cell towers or routers, making it impossible to browse the internet, stream videos, or even make a phone call. Section 6. Keeping time, keeping accurate. The importance of stability. So why are crystal oscillators so important? It all comes down to their incredible stability and accuracy. Unlike other types of oscillators, crystals vibrate at a very precise frequency that remains stable even with changes in temperature, pressure, or age. This stability is crucial for many applications, especially in timekeeping and communication. Imagine your watch gaining or losing a few seconds every day. It wouldn't be very reliable, would it? Similarly, in communication systems, even slight frequency deviations can lead to signal interference and dropped calls. Crystal oscillators ensure that our devices stay on track, providing us with reliable and consistent performance. Section 7. The future of timing, smaller, faster, better. As technology advances, so too do the demands placed on crystal oscillators. Scientists and engineers are constantly working to develop smaller, faster, and more precise oscillators for next-generation electronics. One exciting area of research is in micro-electromechanical systems, or MEMS oscillators. These tiny oscillators are built on a microscopic scale, offering significant size and power consumption advantages over traditional quartz crystals. MEMS oscillators are already finding their way into smartphones, wearables, and other compact devices, paving the way for even smaller and more powerful electronics in the future. It's an exciting time for the world of timing technology. Section 8, Crystal Clear, a quick review. We've covered a lot of ground today, so let's recap the key takeaways about crystal oscillators. They are like tiny timekeepers that keep our electronics synchronized. They work using the magic of piezoelectricity, where crystals vibrate when electricity is applied. Crystal oscillators are found in countless devices, from clocks and watches to smartphones and computers. They are crucial for accurate timekeeping and reliable communication. The future of timing is exciting, with MEMS oscillators leading the way for even smaller and more efficient devices. Section 9. Keep on oscillating. So there you have it, the fascinating world of crystal oscillators. These tiny components play a vital role in our technology-driven world, keeping everything running smoothly and in sync. Next time you check your phone or listen to the radio, take a moment to appreciate the humble crystal oscillator, the unsung hero of modern electronics. Keep on oscillating.